Welcome to homework.
Okay, we have several alkenes here, and we've got to determine if they are cis or trans or neither. So the first alkene is a double bond with a butyl chain and another butyl chain. And this is indeed trans. How do we know that it's trans? Because if we add in protons, right, and we divide this double bond in half, and then we assign the highest priority on each individual carbon. So the butyl chain is the higher priority than hydrogen on that side for that carbon. And on this carbon, this butyl chain is higher priority than the proton. We find that these two groups, the high priority groups on the alkene, are across the dotted line from each other. They are trans to each other with respect to this double bond. Right? They're on opposite sides of the double bond. Right, so this is a trans molecule. The next that we are given, we've got an ethyl chain here, an ethyl chain there, and then we've got this cyclobutane, and then another ethyl chain here. Is this cis or trans? This is neither. How do we know it's neither? Because on one of the carbons, we have two identical groups, right? They're both ethyl. And whenever you run into an instance where you have two of the same priority group or the same exact group on a carbon, you don't have cis-trans isomerism. So this is neither. Okay, what's the next one? C. Okay, so here we've got a double bond. And above this, we have, I'm just going to write ACOH for acetic acid. And here we have let's see, COOH. And down here we have COOH. And right here we have OH. Okay. So maybe something that would help is I'll actually write this one fully out. So it's a carbon, and then there's the COOH. Okay. So yeah, this is probably a cis-trans isomerism, right? Okay, let's look at carbon at a time. Which one has the higher priority? This one, because it's a carbon attached to oxygen twice, whereas here we have a carbon attached to hydrogen, and carbon. Right, so the higher priority of the two is this one. I'll put a number 1 next to it. Okay, now we look at this carbon. We've got an OH, right? And then we've got a COOH. Well, oxygen is higher priority than carbon, right? So this is going to be the higher priority of the two, and they are across the double bond from each other. So this one is trans. Okay, let's look at the next one. Got a methyl and an ethyl, a methyl, and then the hydrogen, right? So same idea, carbon at a time. Let's look at this carbon. We've got ethyl versus methyl. Ethyl is higher priority. Okay, now this one, we've got methyl versus hydrogen. Methyl is higher priority. These are on opposite sides of the double bond from each other. So this is also trans. Okay, one left. Okay, I'm going to abbreviate these benzene rings as pH for phenyl, because they are actually phenyl groups, not benzyl groups. Okay, and then CY for cyclohexane. Okay, and then this is a propyl chain. So one at a time, we'll say, okay, what's the higher priority, phenyl or propyl and propyl? Well, I'll draw this in so we can see why it is the way that it is. Okay, so we're basically comparing this carbon to this carbon. This carbon is attached to two hydrogens and another carbon. This carbon is attached to carbon, carbon again, and carbon. So if we compare carbon, hydrogen, hydrogen to carbon, 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 they're tied here, but when we get to here, the carbon wins. So the phenyl ring has higher priority than the N-butyl chain. Okay, so put a 1 next to the phenyl because it's the higher priority. Then we're comparing cyclohexane to phenyl, and phenyl is higher priority for the same reason. This one's next attachment is carbon, 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 and the cyclohexane's next attachment is carbon, carbon, hydrogen. So when we get to the third atom that the carbons are attached to, the phenyl ring will win. Our priority is phenyl, and the highest priority groups are across the double bond from each other, so this one is also trans.